Before the Big Bang, there was no before. No time, no space. No clock ticking down to zero. And yet physicists keep asking what came first anyway, because the alternative, that nothing caused everything, feels almost impossible to accept. Right now, the observable universe stretches 93 billion light-years across. Every galaxy, every star, every atom in your body traces back to a single point, smaller than a grain of sand. But what's even crazier is that point may not have been the beginning at all. It may have been a doorway. The first theory is called the quantum fluctuation model. It suggests our entire universe began as a tiny ripple in an empty, timeless void, a void governed by quantum mechanics rather than nothing at all. Empty space, according to this idea, is never truly empty. It seethes with particles blinking in and out of existence for fractions of a second. Take that seething background and let one fluctuation grow uncontrollably instead of vanishing, and you get a universe. Physicists have run the math since the 1970s, and the numbers allow for it. But here is the unsettling part. If this theory is correct, our universe was an accident, a statistical fluke in a sea of nothing that happened to tip the wrong way. And if one fluke happened once, nothing stops it from happening again. Somewhere, right now, in a void we cannot see or touch. That leaves us with a stranger question. What if our universe was never alone to begin with? Eternal inflation answers that question, and the answer is worse than you think. This theory proposes that the rapid expansion that shaped our early universe never actually stopped everywhere. It only stopped here, in our pocket of reality. Picture inflation as boiling water. Bubbles form constantly, and each bubble that stops boiling becomes its own separate universe, frozen into its own set of physical laws. Ours was one bubble among an uncountable, possibly infinite number. Some of those other bubbles could have different gravity, different particles, or no stable matter at all. The theory was formalized in the early 1980s and remains one of the leading frameworks in cosmology today. But if inflation truly never ends, then somewhere beyond our horizon, new universes are being born at this exact moment, and we would have no way of ever detecting them. So what happens if two of those bubbles ever touched? That question leads to the collision model, sometimes called the brane collision theory. It imagines our universe as a thin membrane floating in a higher dimensional space, alongside other membranes we cannot perceive. According to this idea, the Big Bang was not a creation from nothing. It was the shock wave of impact when two of these membranes collided. Imagine two sheets of paper drifting through a room, invisible to each other until the instant they touch, and in that instant, an entire universe ignites. Versions of this theory emerged from string theory research in the late 1990s and early 2000s. If it's true, our Big Bang was not unique. It could have happened before, and it could happen again, each collision resetting reality from scratch. If universes can collide, then maybe they can also die and come back. That's where things take an even stranger turn. Cyclic cosmology suggests the universe does not begin once. It repeats, expanding, collapsing, and igniting again in an endless loop, stretching backward and forward without limit. No first moment, no final moment. Just cycle after cycle. Imagine a universe that expands for trillions of years, thins out into cold darkness, and then contracts back into a single point, only to bounce outward again as a new Big Bang. Some versions of this model, developed by theoretical physicists in the early 2000s, replace a violent collapse with a smoother bounce, avoiding singularities altogether. But here is the unnerving part. If the cycle is truly eternal, there is no way to know which cycle we are living in. Or how many came before us and vanished without leaving a trace? And if there is no true beginning, then maybe the question itself is broken. That brings us to the no-boundary proposal, one of the most mathematically elegant ideas on this list. It suggests that asking what happened before the Big Bang is like asking what lies north of the North Pole. The question assumes a direction that may not exist. In this model, time itself becomes smooth and rounded near the beginning, blending into space in a way that removes the sharp edge we call a starting point. Developed by physicists in the 1980s using imaginary time in their equations, the proposal does not deny a beginning. It denies that the beginning needs a cause. No before, no after, just a boundary that curves rather than cuts. If this idea is correct, then humanity's oldest question, what came first, may not have an answer, because it was never a valid question to begin with. If you have made it this far into the origins of everything, drop a like and subscribe, because the next theory does not just challenge how our universe began, it challenges whether time ever had a true starting line at all. The next idea removes time from the equation entirely. It's called the block universe, and it treats past, present, and future as equally real, existing together rather than time flowing from one to the next. Under this view, the Big Bang is not something that happened long ago. It is a fixed location in a four-dimensional structure, no more special than any other moment. Picture a film strip. Every frame already exists, stretched out from start to finish, and consciousness simply moves through the frames, like a projector light passing over pictures that were always there. This interpretation grows directly from Einstein's relativity, formalized through work in the early 20th century. But if every moment already exists, unchanging, then asking what came before the beginning may be like asking what exists off the edge of a photograph. But even a frozen timeline needs an origin for its very first frame. And that leads somewhere stranger still. The multiverse of mathematical structures proposes that our physical universe is not made of matter at all at its deepest level. It is made of mathematics itself, and every mathematically consistent structure necessarily exists as its own universe. Under this framework, physical laws are not descriptions of reality. They are reality. Take any equation that holds together without contradiction, and somewhere it becomes an actual breathing cosmos. This idea, proposed by a physicist in the early 2000s, suggests our Big Bang was simply one solution among infinite equations, all equally real, all equally valid. We are just one answer in an infinite exam of possible answers, and nothing about us was ever necessary. And if mathematics can birth universes, then perhaps information can too. That brings us to the holographic principle, an idea suggesting our entire three-dimensional universe might be a projection encoded on a distant two-dimensional surface, the way a hologram stores a three-dimensional image on a flat card. Under this theory, all the information needed to describe every planet, every star, and every galaxy could be written on a boundary at the edge of space-time itself. Researchers studying black hole physics developed key elements of this idea in the 1990s, based on how information behaves at an event horizon. If our universe really is a projection, the Big Bang would not be a moment of creation. It would be the moment the projection switched on, and everything since then, every heartbeat, every sunrise, would be shadows cast from a deeper, hidden layer of reality. But even a projection needs a machine generating the image. So what actually pressed play? That question brings us to the simulation hypothesis, a theory that leaves physics almost entirely and steps into philosophy. It suggests our universe, including the Big Bang itself, could be a highly advanced computational construct, run by an intelligence operating outside the system we perceive as reality. Philosophers formalized modern versions of this argument in the early 2000s, built on probability, not evidence, resting on how advanced civilizations might eventually create countless simulated realities far outnumbering the one true original. If this theory holds any truth, the Big Bang was not a natural event at all. It was a keystroke and initialization command. The moment someone or something chose to run the program we call existence. And that leaves us with the most unsettling possibility of all. Quiet compared to everything before it, but heavier in what it implies. Some physicists argue we may never know what came before the Big Bang, not because the answer is too complex, but because our universe may be the only evidence we will ever have access to. Every theory on this list is mathematically consistent. Not one has been proven. And somewhere in that uncertainty sits the strange comfort that existence itself, however it began, produced something capable of asking the question in the first place. If this journey into the edge of everything kept you here until now, subscribe and stay close, because the universe still has darker doors left to open, and you will not want to miss what waits behind them.